Hello and welcome to the demonstration video of the Dell Storage SC Series Volume Qos feature. I am Darren Schmitz, part of the Dell Storage engineering team, and today we are going to be talking about the Volume Qos. First on the agenda, we'll explain the use cases for Volume Qos. Then I will get into showing, enabling, and configuring Volume Qos. I'll show the server load equalizer. I'll show profiles and priorities, IOPS and bandwidth limits, and last but not least, group Qos profiles. So first, let's talk about Volume Qos. With shared storage, one of the common challenges is known as the noisy neighbor syndrome. This is where one load on the array happens to dominate the resources and deprive another workload from the necessary I/O that is required for the application to operate proficiently. Volume Qos addresses this by allowing users to set priorities and bandwidth limits or IOPS limits on particular volumes to throttle the workloads. Let's get in and show this. So if you'll notice in my charting, we have a normal workload simulation running across 6 volumes, across 6 virtual machines running on a vSphere cluster. If you'll notice in the charts, all of the volumes are doing about 110,000 IOPS at 3 milliseconds of latency. If we look at our mission critical volumes, they are doing about just under 40,000 IOPS per the simulation. Now, in a typical environment, the noisy neighbor is going to come along and disrupt this traffic, increasing latency of the production or mission critical workloads such that it affects the users. So let's simulate that. So the first thing I'm going to do is introduce the noisy neighbor. To do that, I'm going to open up an iometer profile that I previously created and get that started. The first thing that we're going to notice in the volumes after the sampling period is that the total IOPS due to the noisy neighbor workload being ingested are going to drop sharply. As you'll notice in the first sample period, it already dropped from 120,000 down to under 10. If we look at our mission critical workload, you'll see that the latency has just spiked from just under 3 milliseconds to about 28 milliseconds of latency. This is causing a sharp and drastic decrease from about over 40,000 IOPS down to just 6,000 IOPS for that particular workload. In this case, the users are most likely going to call and complain that their application performance for that particular application has been drastically decreased. So let's enable the QoS feature and try to alleviate that bottleneck. The first thing I'm going to do is I'm going to right click on the array and say Edit Settings. When I go to the Storage tab, there are 2 boxes that I need to check to enable QoS and a latency goal that I need to set. The latency goal is in microseconds. In other words, there are 1,000 milliseconds in each second. So you can basically set this, by default it's set to 15 milliseconds. The latency goal is effectively a value that you set for the array that takes into account the system-wide latency. In layman's terms, what this goal means is that any time the system latency goes above 15 milliseconds, that the I/O scheduling will start occurring. It is wise to set this just above the normal operating latency of the array, such that any deviation from the normal I/O patterns will enable the load equalizer. In this case, since we knew that our latency for our production workloads was good at 3 milliseconds, we can set this to 4 milliseconds of latency and hit OK. Now that the load equalizer has been enabled, we can go look at our Qos profiles. By default, the 6 volumes are placed into the default profile. Effectively, we've all given them equal priority. But in this case, we don't want everything to be treated equally. Right now, the load equalizer is trying to ensure fairness across all 6 volumes, when in actuality, we do want the mission critical volumes to have a higher priority than the VM development profile that are being the noisy neighbor right now. So the first thing I'm going to do is I'm going to apply the high priority to the mission critical volumes. Next, I'm going to assign a low priority to the noisy neighbor in the VM development group. When you look at the performance of the mission critical group now that it's been given a higher priority, you'll notice that the IOPS have went from 6,000 to about 17,500. And you'll notice the total latency has dropped. The one thing that you're going to notice from this is the gray line. And to better show it, let's look at the noisy neighbor. Because we've given the noisy neighbor the lowest latency profile, you'll notice that this gray line represents the injected amount of latency. So in this particular case, we can look and see that the I/O balancer is adding 46 milliseconds of latency to the low priority workloads in order to give some IOPS back to the mission critical volumes. However, if we look at this, you'll notice that the latency is still 7.5 milliseconds. Maybe in this case, the mission critical workload is not acceptable at 7.5 milliseconds. To further limit the workload so that the mission critical can have more IOPS or bandwidth, we can apply different profiles to it. For example, we have a volume limit profile. If we edit the settings of this, you'll notice that it too is given low priority, but we have a hard cap of 500 IOPS. So let's apply that to our noisy neighbor. I'll right click, say apply to volumes, and apply that to the noisy neighbor. Now if we look at the noisy neighbor volume, the first thing you're going to see is a new purple line being introduced into the graph chart. This purple line indicates what the maximum IOPS allowed are. This makes it easy to identify any kind of limits that may be affecting a workload. As you can see, as the IOPS are reduced, the latency is increased. Now if we flip back to our mission critical volumes, we'll notice that they are just under 40,000, but if we drill into the latency, we are now under 5 milliseconds of read latency and under 2 milliseconds of write latency. Maybe in this case, the workload has been adjusted such that the users aren't going to complain anymore. Similarly, if we have a workload that starves the front-end bandwidth, we can apply a volume limit to regulate the megabytes per second. Let's apply this to the volume instead of the IOPS limit. So when I select it, I can say OK. Let's look at the VM development load. If you'll notice, the limit for the IOPS has went down, and a new limit for the bandwidth has been introduced. As we limit the front-end bandwidth to just the 300 megabytes per second, you'll notice that the latency is artificially increased such that it reduces the total IOPS and in turn reduces the total bandwidth being used. Now, if we flip back to our mission critical volumes, you'll notice that they are reaching they're reaching about the same value that they left off at, and the latency has returned to just a little bit above where it was normally. Next, let's show the group Qos profiles. To do this, first thing I'm going to do is remove some of the workers from the workload. and start that back up again. If we look at the workload, you'll see that it's increasing over the previous values. Since these are the only two workloads running, you'll notice that they are capping out at 70,000 IOPS. Let's apply a group limit to both of them. Now remember, these group limits apply as an aggregate. So the total of each of their IOPS can be 20,000. So in other words, 10 for each, maybe 5 for one, 15 for another. But together, they can never exceed 20,000 IOPS. If we flip back to the production folder where we have our two loads being generated, you'll notice that they drop from the 70,000 down to the 20,000 near immediately. The system has added in artificial latency to slow the workload down. You'll notice that now the workloads are doing the 20,000 IOPS. If we drill down into each of the workloads, you'll notice that one of them is doing approximately 11,000 IOPS, and the other volume is doing approximately just under 10,000 IOPS. But together, they're not exceeding the 20,000. The key to this group limit is that, again, they are added together to form the maximum. So for example, if I go in and I stop yet another one of these, you'll notice that in the production group, although the single volume can max up to 20,000 IOPS, that the aggregate one is 20,000 IOPS, the other is 0 IOPS, you'll notice that they can both burst up to the 20,000, but together they can't exceed the 20,000. So if you look, this volume is going back up to the 20,000, while this volume is doing 0 at this time. And that concludes the demo. Thanks for watching. For more information, please visit www.dell.com/techcenter for all the recent documents about the Volume Qos feature.